Good morning, math students, or good afternoon, or good evening, whatever it is for you. Maybe it's middle of the night. I don't even know. But whatever it is, I'm glad you're here. I bet you are too. You're like, wow, Mr. Krause and Miss Newman are saving me. But I gotta sit here and watch him for like an hour and he hasn't shaved and his hair's really long. I don't get it. Like, that's disgusting. Shave. Maybe in the next video. We'll see. Anyway, my videos, otherwise known as our videos, can be found, that's Miss Newman and I, at nkinfinity.com. At some point, I'm actually going to put down exactly what's in the videos online so that you can make a better informed decision. But right now, what's going on is they're like nicely in order. Day 1, day 2, day 3, day 4, day 5. You missed day 3? Go watch day 3. Get your notes from your teach and go watch day 3. My name is Mr. Key for the next hour. All right, kids. All right, let's get going. Graphing rational functions. Again, when you go home and your parents say, what did you do today? How was your day? Well, Mom, I was graphing these rational functions, and we had these asymptotes and all this stuff and vertical and horizontal and stuff like that. And they're like, whoa, way too much information. Just sit down and eat. How many Pokemon did you catch today? What? What's a Pokemon? Anyway, a rational function, has the form of f of x equals p of x over q of x, where p of x and q of x are polynomials, and q of x can't equal 0. Why can't q of x equal to 0? That's the denominator. Denominator cannot equal 0. Why? Because that would make it undefined, and you're not allowed to make it undefined, so our denominator can't be 0. Well, let's take a look at the parent function, because we are talking always about parent functions. You know a lot of them. You know a line, you know a parabola, you know an absolute value, you know a cubic, you know a fourth degree, you know a fifth degree, sort of. Now you know a rational function. The parent function of a rational function, the parent function, is either written y equals 1 of x. Mr. Krause, that's not a fraction. You just said rational functions are fractions. Oh yeah, I forgot. Here it is. Remember, 1 x to the negative 1 is really equal to 1 over x. So its parent function looks like this over here. You see this over here? Should have some arrows here. Somehow I missed an arrow there, and I probably just cut it off down there. Anyway, the parent function looks like this. And then, why does it look like that? Why in the world does it look like that? Well, let's think about what the domain is. It looks like it goes forever and ever to the left. It looks like it goes forever and ever to the right. But as I come towards the middle, it looks like it's getting closer and closer to the origin, which is 0, but it doesn't ever look like it's ever going to make it. And then as I come from the right over here, and I get closer and closer and closer and closer and closer, it looks like I'm getting closer to 0 as well, but I never touch it. So the domain is the set of all reals. How about this? The set of all reals except x cannot equal 0. Or, how about let's write it nicely. X is in the set of all reals such that x cannot equal 0. Oh yeah, set builder notation. You probably also could have written just that x equals can't equal 0. That would be too easy though. All right, how about range? Well, wait a second. It goes forever and ever up. It goes forever and ever down, but as it gets closer and closer to this line, which is the x-axis, when y is equal to 0, it doesn't look like it's touching that either. So, set of all reals except y cannot equal 0. Or, in other words, y is in the set of all reals such that y cannot equal 0. You have to understand what that means. This line means such that this little e funky looking thing right here that says in the set of, and then this little line right here means such that. Just, you'll hear your teachers sometimes say that. You could have also just said y cannot equal 0. You could have just written y cannot equal 0. That's a simple mistake. Whatever. Asymptotes. Let's define what an asymptote is. Every little boy likes to say the word asymptote because they feel like they're getting away with swearing. The girls are going, really? Why don't you grow up? This is why I date older men and not you, boy. And the boys are like, whatever, asymptote. Asymptote. Grow up. I was talking to myself. Sorry. An asymptote. And I got to use and because it's got a vowel here. A-S-Y-M-P. I cannot spell this word. P. And obviously I can't write. I'm on that corner of my... I got to get a bigger tablet. That's the next thing. As soon as I make $1 million, I'm getting a bigger tablet. Wait, if I make $1 million, do I have to keep doing videos at 5 o'clock in the morning? No! But I'll do it anyway because for you. An asymptote is a vertical... Well, it actually doesn't matter if it's a vertical line. It's a line, because sometimes you have slant asymptote. A line... a graph approaches, but does not cross. I know it looks like gross. Actually, I think sometimes you can cross it. So why don't we say this? A graph approaches more and more closely. I don't want to say anything that's exactly wrong, more and more closely. This is probably more accurate. I believe there are times when you cross an asymptote and then come back towards it. I don't know. I don't teach those upper level classes. I just teach math at the Algebra 2 level. This is upper level enough for me. So let's think about what our asymptotes are. I'm going to draw one in green. Remember how we were trying to get closer and closer and closer and closer and closer to this line, but we never quite got there? Well, that's the line y equals 0. So that's an asymptote. And then we're also trying to get closer and closer to this line, but never touch it. And so that is a vertical asymptote. The green line is a horizontal asymptote. The blue line is a vertical asymptote, and the equation to that line is x equals 0. So I have I have a horizontal asymptote, which I'll call HA. That is y equals 0. And I have a vertical asymptote, which is x equals 0. By the way, if you want to know what this shape is, if you're just looking at the shape here, this shape is called a hyperbola. Looks like two sideways, crooked parabolas. We call it a hyperbola. Yay, I learned something new today. Go home and tell Mom that. Mom, what did you learn today? I learned about rational functions and vertical and horizontal asymptotes. I can say it. And we also learned about hyperbolas, Mom. Not hyperbole. That's, I think, something in English. Hyperbola. Oh, man. Thank you, Dunkin' Donuts. You are my hero. You save the day and make life worth living. You are awesome. You make my wonderful kids... What? You don't like my commercial? Dunkin' Donuts doesn't like it either, apparently. Describe the transformation. Okay. Now, we've been doing this a long time, kids. We've been doing this this is Unit 5. I've talked about transformations quite a bit. And notice over here, my h, my whatever value this is being attached to the x. Notice my h over here is being attached to the x. Notice here my k is away from the x. Away from the x. Now you should remember what those means. What those means. That's not English. What those mean. When you're on right next to the x, that's the inside. Remember, inside, right next to the x. What does that mean? That means we are going to do a translation. That's the official word. But we're going to be going where? Left or right. I know I just wrote right or left, but left or right. We're going to be going left or right. So where are we going to be going? Well, I don't even care what h is. It's the sign. Remember, this is always going to be backwards. So if I say positive and I'm on the inside, I mean I'm going to go left h units. If I'm on the inside here, I'm going to be a translation. Use the right words. Right. Because now I'm subtracting, so now I'm going to go right h units. Now for the ones that are on the outside or away from the x, excuse me, those are just normal, but this is going to be translations. These are going to be translations up and down. So when it's away from the x or on the outside, it's going to be up or down. So this is going to be, and then it's just normal. So if I'm adding k, we're going up k units. Translation down k units. Any of this make sense to you all? I hope so. And finally, the only difference, what I got here, whoa, let's back up the crazy train. That should be an x. I wish I had my pen here to fix that. That should be an x. Hopefully it's fixed on your sheet. Multiply by a negative. Remember, that's a reflection over the x-axis. Over x-axis, or in the x-axis if you prefer. Well, what does that mean? What does that mean? Let's see. Wait a second. Oh, let's talk about a couple other things real quick. And then we're going to get to graphing because it's going to be fun. Rational functions take the form of fractions. We talked about that. A rational function is a fraction where you have a polynomial divided by a polynomial. Now, does it mean that the polynomial can be 4? Sure, 4 is a polynomial. It happens to be a monomial and a constant monomial, but it can be that can be considered that. We know that fractions cannot have a, that's right, John. I always say John because it's easy. A 0 in the denominator. Otherwise, it is undefined. So, what would make this undefined? Oh, 6. Right, positive 6 would make that undefined. What would make this undefined? Well, you know, you could factor that. X plus 4, x minus 4. So, wouldn't you say negative 4 and positive 4? If you factored this one, you'd say what? X plus 8. X minus 2, multiply to negative 16, add up to negative 6. So what can't x equal here? What would make this 0? What would make this 0? Oh, negative 8 would make the first one 0. Positive 2 would make the next one 0. So those can't be. Now those numbers are going to come and become important parts when we talk about translations of the parent function, which we will get back to after I have a drink of coffee and I record and I save this. Let's take a look at this function. There is our parent function graphed for you. It is a hyperbola. All right. My asymptotes are right here at, I know that's hard to do, x equals 0 and y equals 0. Now, what's going on here? We got a plus 3. We have a plus 3, and we just talked about the fact that this is going to go up 3 units. So I think it's good to sketch what this looks like and then talk about domain and range. So if this thing goes up 3 units, wouldn't this asymptote go up 3 units? Up. So now my asymptote, which I really should draw with a dotted line because it isn't part of the graph. Right there. Now, did it go left or right at all? Nope. So I still have this as an asymptote. Okay. Now you just graph this function. And you do your best. You try to show that you're going to get closer and closer. It actually goes through this point. So it's going to go through this point right here. You'll notice that it always goes to that point unless we have a dilation, which we'll have. And goes like that. There it is. All right, so let's talk about the domain. Left and right, what can't x equal? Well, x can't equal 0. Because still, I can go forever and ever to the right, forever and ever to the left, but I still can't hit here where x equals 0. Now, where can't y equal? Well, this one's gotten changed, right? So we're going to go, and y gets closer and closer and closer and closer to 3, or closer and closer to 3, but it can't touch this, 3. Now, the reason it can't be 3, if you come down here, in order for this to be 3, wouldn't this fraction here have to be 0? That 1 over x would have to be a 0. There's no way to make 1 over x, there's no way to make that equal to 0. It can't equal 0 because the only number I could put in the denominator would be 0, but it can't be 0. So there's no way to make it 0, so there's no way this could ever equal 3. Vertical or horizontal asymptotes. Horizontal asymptotes are right, they're going the ones going left and right. Well, there it is right there. There's my horizontal asymptote. Oh, dotted lines, dotted lines, dotted lines. My horizontal asymptote is y equals 3. My vertical asymptote did not change, still x equals 0. I'm going to try to get my big head out of the way. If I don't, I wrote x equals 0 there. All right, example 2. Again, I'm giving you the left as the parent function just as a reference, okay? Just as a reference. So what happened here? Oh, wait. I'm inside the parentheses, next to the x. That means this is going to be a shift left or right, depending on what this number is. And remember, it's backwards. Backwards. So we're going to shift left or right. So that means my vertical asymptote is, in this case, is going to go 1 unit to the right. Okay. Did I go up or down at all? Nope, sure didn't. There it is. And I just draw in. Again, it goes to this point, and it's going to go through this point, unless I have a dilation. So you can just kind of go there and go there, and then go there, and then go there. All right. Now, I can go forever and ever to the left. I can go forever and ever to the right, but I cannot, in this case, equal 1. And not only that, think about it. If I put a 1 in here, doesn't that make that denominator equal 0? Sure. So x cannot equal 1. What can't y equal? Well, I didn't go up or down at all, and so y can get closer and closer and closer to 0. Y can get closer and closer to 0, but it will never equal 0. What is my horizontal asymptote? Didn't change. That one's y equals 0. What is my vertical asymptote? That one moved 1 unit to the right. Moved 1 unit to the right, so that's my horizontal or my vertical asymptote is x equals 1. All right, kids. Again, I continue to give you that the hyperbola on here on the left is just as a reference point, and think about where these asymptotes are. We have an asymptote at y equals 0. Remember, that should be a dotted line, and x equals 0. And then this tells us what we're going to do, okay? So what does plus 2 tell us to do? That means we're going to move left or right. Grab your hand and go like this. Left or right, 2. In this case, because it's positive 2, we're going to go left 2. We're going here. We're going to go left 2. So my vertical asymptote, which was right here, moves to the left. X equals negative 2. So then I can come over here and say, okay, I know that x can't equal, sorry about not giving you much room, x can't equal negative 2. All right, we're going to go down 4. So there was my horizontal asymptote. Now I'm going down 4. Ding, 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 ding. So I know y can't equal negative 4. Gosh, I got to move those over. That drives me crazy. Oh, man, on my my sheet here, they look like they've been moved over. Okay, so it goes to this point. And it goes to this point. And it goes to this point. And it goes to this point. All right, horizontal asymptote. What value can y not equal? Well, y can't equal -4. Oops, excuse me. What is that horizontal asymptote? Oh, it's gone. Y equals -4. Did you notice this kind of gives you this? This kind of gives you this. And then x equals -2 is my vertical asymptote. Moving on, chillin'. All right, the -3. By the way, now you should probably pause it and try it on your own. Oh, you're back. Great. The -3 says we're going to move to the right 3. Boom, 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 boom. Boom, 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 boom. X can't equal 3. The positive. The positive 1 means we're going to go up 1. Y can't equal 1. So, dot there. Do you see how easy this is now? And it's more fun to do graphing when you go. By the way, if you were in my class and you did this, because you're lazy, you did and you cross that, I'd give you a hard time. I'd make up a point. I'd be like, all right, you know it's an asymptote, you shouldn't cross it. Be relatively neat. Like, I know it's impossible for me to be neat on this, almost impossible. But be relatively neat. Show that it is an asymptote. Oh, what is my horizontal and vertical asymptote? Well, my horizontal asymptote is y equals 1. What is my vertical asymptote? X equals 3. Actually, this is my vertical. That's my horizontal. And by the way, we abbreviate these a lot. HA and VA. Vertical asymptote and horizontal asymptote. Again, pause it. See if you can do it on your own. Whoa. Maybe we need to talk about this one, kids. We got something else going on here. Got a little something going on here. Difference is 4. Do you notice it's not going through this point anymore? It's not going through this point anymore. Like when I plug in 2, 4 over 2 is 2. So it's moved away 2 units, like 4 diagonal units or something away. That's not much of a big deal. That just means it's going to be not going through this point, and you shouldn't go through this point if you see a dilation. You should go through an accurate point. And you know we're going to go right to up 2. So that's what we're going to do on the next one. But we got to figure out where we're going. So our domain is we can't equal -1. So -1. That becomes my vertical asymptote. That means I'm here and I'm going to move to the left 1. Because it's +1, I'm going to move to the left 1. Ding, 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 ding. Ding, 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 ding. The -5 means I'm moving down 5. Ding, 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 ding. Boom. Okay. Now don't go through this point. Go through this point. Don't go through this point. Go through this point. Right? Use my model over here to help you with that. Okay. Now it's just pretty much the same. Go towards the axes. I mean, not towards the axes. Go towards the asymptote. Go towards the asymptote. Go towards the asymptote. Go towards the asymptote. Bam! Oh, what can't y equal? Well, y can't equal -5. Oh. What's my horizontal asymptote? Y equals -5. What's my vertical asymptote? X equals -1. What are you waiting for? Do it on your own. I'm enjoying some Dunkin' Donuts coffee. When I watch my students do work, I drink Dunkin' Donuts coffee. It is the sustenance of life. Nailed it! Another amazing commercial. I know. Here we go. You should already be done. We're going to move to the... Where are we going? Remember, next to the X, we're going left to right. We're going to go backwards. We're going to go right 5. Ding, 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 ding. Ding, 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 ding. We're going up 2. This means X can't equal +5. Y can't equal +2. Those tell you my asymptotes. Y equals 2. X equals 5. Got the wrong sheet in my hand. Checking my answer key just to make sure my answer key is right. All right. And then we're going to go not through. Notice we're not going through this point or this point. We're going to go, because we have a dilation, we got to go a little bit further away. Pacham. Kacham. Close. 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 Done. Go ahead. Pause. I was just giving you some faces to pause it on so you can do it, because that was kind of cool. Are you holding your way? All right, that's my last place. Okay. All right, well, welcome back. Thanks for coming. I don't know why I keep picking 4. Oh, 4 because it's kind of easy. So anyway, let's see. We move to the right 3. We move down 1. All right. Minus 1, 3. Y equals negative 1. X equals 3. And 2 away. 1, 2. Ka-ching. Gone. Ka-ching. Don't cross it. Ka-ching. Gone. That was sloppy. That was sloppy, Krause. It's ridiculous. Come here for some good math work and you just sloppy. You sloppy. I'm not sloppy. All right. We have something changing? We got to change. All right. We don't go to the left. We don't go to the right. It looks pretty much, for all intents and purposes, the same except for this. See? No negative, negative. And you got to remember that means we have a reflection in the x-axis. Right? So my horizontal and vertical asymptotes aren't going to change. So when I come over to here and I say, oh, my horizontal asymptote's here, or my vertical asymptote's here, my horizontal asymptote's here. By the way, don't be this sloppy when you draw your horizontal and vertical asymptote, and it's good to do it in colored pen. But, so those are both 0, 0, y equals 0, x equals 0. By the way, if you mess these up and put x equals 0 and y equals 0, you lose 2 points. 1 for each, because they're both wrong. Make sure you understand a horizontal line is a y equals, and a vertical line is an x equals. If you forget, go over to your calculator, graph the line y equals 5, and make sure, oh yeah, y lines go like this. That means the x lines got to go like this. But instead of it being up here and down here, we now have a reflection. So we're going to go up here, closer and closer, closer and closer, down here, and closer and closer. Notice how this piece reflected up here and this piece reflected down here. That's all it means. That's all we're going to do. That's what the negative is going to give us, a reflection. That can't be too bad. Let's try one. Oh, we're going to try all crazy stuff now. We're going to get crazy. Crazy. Hold on, I got to stop. Okay. They don't get any more difficult than this. We got everything going on here. We got reflections. We got translations. We got all kinds of crazy stuff. No rotations, though, because we don't have to do rotations. But we do have some reflections and some translations, so we got to work on those. Let's talk about the asymptotes. Don't worry about the reflection right now. Let's talk about the asymptotes. Okay. This asymptote says we're going to move left 2. It's backwards. Bam, bam. Make it neat. Try to make it neat. Left 2. Down 3. So I can answer all these questions over here. X can't equal negative 2. Y can't equal 3. Y equals, excuse me? How about Y can't equal negative 3? That thing is driving me crazy being there. So Y can't equal negative, Y equals negative 3 is my horizontal asymptote. My vertical asymptote is X equals negative 2. So now I've got my asymptotes. All right. Now, normally, we don't have a dilation here. Oh, I thought we had everything. We don't have a dilation here. So normally it would go through this point, but because we also have the reflection, it's not going to go through that point. It's going to go through this one, closer and closer, closer and closer. Normally it would go through this point up here, but now it's going to go through this point down here. Like that. All right, so we don't need these 2 points. We don't need those. Okay, there it is. That's it. Doesn't get any more difficult than that. Oh, all right. This one you should try on your own. Pause it and come back. Okay, welcome back. Thanks for coming back. Oh my gosh. We're going to go to the right 3. 1, 2, 3. We're going to go up 5. We have a reflection. So we're not in the here and here. We're going to be up here and down here. So 1 point, and then round it, bend it, come over there. 1 point here. Put some arrows on those things. Don't cross the axis. Okay, so what can't x equal? X can't equal positive 3. What can't y equal? Y can't equal positive 5. Y equals 5 is my horizontal asymptote. X equals 3 is my vertical asymptote. So we're going to change things up a little bit here. Just a wee bit. Notice this is my denominator. And a vertical asymptote is what makes the denominator, I don't know why I put bottom. I should put denominator. The denominator equal to 0. So in this case, if I solve for x, I would get cx equals negative d, or x is equal to negative d over c. And that would give me my, what makes the denominator equal 0, that would give me my vertical asymptote, my up and down asymptote. The horizontal asymptote comes, this isn't exactly always true, but for our purposes for today, you'll learn a little bit more in pre-calculus, I believe, is going to be a coefficient, as long as these degrees are the same, this is degree 1 and this degree 1, it is going to be a coefficient of the leading coefficient. So the the horizontal asymptote will be a coefficient of the leading coefficients. So in this case, A over C. So all I want to do is go through a couple of examples and show you how this is done. Well, I'll do one graphical example. So over here, what is my, let's say, what do we do? What can't x equal? X can't equal 3. So I know that my domain is x is in the set of all reals such that x cannot equal positive 3. Or just x can't equal 3. 1, 2, 3. Notice this line right here. There is my vertical asymptote. Now what would make, now my horizontal asymptote is going to be a ratio of the leading coefficient. So in this case, my horizontal asymptote is, so my vertical asymptote was x equals positive 3. My horizontal asymptote is y equals 2 over 1, or just 2. And if I notice over here, draw in the line y equals 2, notice it's getting closer and closer to 2, but not hitting it. So y equals 2. So y is in the set of all reals such that y cannot equal 2. You could just say y can't equal 2. And my asymptotes then are x equals 3 and y equals 2. Simple. That's it. That's all you got to do. So let's talk about it. Vertical asymptotes, the denominator equals 0. Horizontal asymptote, y is equal to leading coefficient over leading coefficient, if you want to do it like that. So in this case, my vertical asymptote, what makes this equal to 0? X equals 0. Let's go through all three of these. What makes this equal to 0? I got to do a little bit of work there. 4x minus 2 equals 0. 4x equals 2, or x equals 1/2. Okay, and this last one here, we got to set this thing equal to 0. So we're going to do negative 3x plus 2 equals 0. Bring the negative 2 over, I guess. Negative 3x equals negative 2, or x is equal to positive 2 over 3, right? It's negative over negative, and that makes positive. So x equals 2/3 would be my vertical asymptote. My horizontal asymptote is actually the easy part. You're just going to look at the ratio of the leading coefficients, so long as the degrees are the same. So the degrees are the same here, so that's 1 over 1, or y equals 1. 2 over 4, or y equals 1/2. Negative 1 over negative 3, or y equals 1/3. Simple. Describe the transformations in words that are occurring to f of x to produce g of x. State any asymptotes. Okay, So every time I gave you just the parent function. Every time the parent function, parent function, parent function, parent function. Okay, so you got to remember the difference between this and this, right? The difference between this and this, right? One's on the inside, one's on the outside. So what's the transformation? Let me get a different color. We're going to go, because it's -3 on the outside, we're going to go down 3. So if you're going here and you're going down 3, which asymptote is changing when I'm going down 3? That would be the horizontal asymptote. So instead of being 0, it's going to be y equals -3. So, and I should state this, horizontal asymptote, y equals -3. Vertical asymptote didn't change. My vertical asymptote is still x equals 0. So I put a 1/4 out front. Anytime you put something out front, that is a dilation. Anytime you multiply, that's going to be a dilation by 1/4. But I didn't move left. I didn't move right, so my horizontal and vertical asymptotes aren't going to change. My horizontal asymptote will be y equals 0. My vertical asymptote will be x equals 0. Didn't change. Bam. Negative out front. That's a reflection over x axis. But again, I didn't move left. I didn't move right. I didn't move left or right. I didn't move up or down. So my asymptotes aren't going to change. My horizontal asymptote will be y equals 0. My vertical asymptote will be x equals 0. Almost done, children. Oh my God, it's so exciting. Oh, this time I'm adding on the inside. When you add on the inside, that's a shift left or right, backwards. So in this case, we're going right. In translation, right 4 units. So if I'm going here and I go right 4 units, here and going right 4 units, what's changing? Oh yeah, my vertical asymptote. My vertical asymptote used to be x equals 0. Now it moved to the right 4 units. That means my new vertical asymptote is going to be x equals +4. My horizontal asymptote didn't change. It didn't go up or down, so it's just y equals 0. All right, we got all kinds of stuff going on here. We have a reflection. Reflection over x axis. We have a dilation of 3. We're going to move to the left. Translation. Left 2 units. Translation. Up 4 units. All right, so over here, and we go left 2. My vertical asymptote went from 0, left 2, to x equals -2. So my vertical asymptote is x equals -2. If I'm here and I go up 4 units, up 4 units, my horizontal asymptote went up 4 units, so my horizontal asymptote is y equals 4. That's it, kids. Day 2 is over. If you haven't subscribed to our wonderful YouTube channel, please do so at this time. I would very much appreciate it. Thank you very much. Thanks for coming to the party. Goodbye, kids. Goodbye. No, really, goodbye. It's over. You got to go. It's got to go. You can't stay around here because it's kind of creepy.